Hello dear students, today we will discuss classification of dosage forms, routes of administration part 2nd, formulation considerations of aromatic waters, solutions, syrups, elixirs and infusions. First of all, we will discuss about solutions. The strength of pharmaceutical solutions is usually expressed in terms of percentage strength, although for very dilute preparations, expression of ratio strength is sometimes used. Percentage weight by volume for solutions or suspensions of solids in liquid. For solutions of gases in liquids, its meaning number of grams of a constituent in 100 ml of preparation. For example, 1% weight by volume is equal to 1 gram of constituents in 100 ml of preparation. Percentage volume by volume. For solutions of liquids in liquids means that number of ml of a constituent in 100 ml of preparation. For example, 1% volume by volume is equal to 1 ml of constituent in 100 ml of preparation. Percentage weight by weight. For mixtures of solids and semi-solids, number of grams of constituents in 100 gram of preparation. Example, 1% weight by weight is equal to 1 gram of constituent in 100 gram of preparation. Now, ratio strength, weight in volume means weight by volume means number of grams of constituents in a stated number of ml of preparation. For example, 1:1000 weight by volume is equal to 1 gram of constituent in 1000 ml of preparation. Ratio strength volume in volume. Volume in volume means number of ml of constituents in a stated number of ml of preparation. Ratio strength weight in weight. Weight in weight number of grams of constituents in a stated number of grams of preparation. Now, solubility determination. The solubility of a substance in a given solvent may be determined by preparing a saturated solution of it at a specific temperature and determining by chemical analysis the amount of chemical dissolved in a given weight of solution. By simple calculation, the amount of solvent required to dissolve the amount of solute can be determined. The solubility expressed as gram of solute dissolving in milliliters of solvent. For example, 1 gram of sodium chloride dissolved in 2.8 ml of water. When the exact solubility has not been determined, general expression of relative solubility may be used. This is table for relative term of solubility is on your screen. Material is said to be very soluble when 1 part of solute dissolved in less than 1 part of solvent. A material is known as freely soluble when 1 part of solute dissolved from 1 to 10 parts of solvent, and a material is known as soluble when 1 part of solute dissolved from 10 to 30 parts of solvent. A material is known as sparingly soluble when 1 part of solute dissolved from 30 to 100 parts of solvent, and a material is known as slightly soluble when 1 part of solute dissolved from 100 to 1000 parts of solvent. Very soluble when 1 part of solute dissolved from 1000 to 10,000 parts of solvent, and practically insoluble when 1 part of solute dissolved more than 1000 parts of solvent and over. Solvents for preparation of solutions. Syrups and elixirs are alcohol, diluted alcohol, glycerin, propylene glycol, purified water. Pharmaceutical solution may be classified as an oral solution, otic solution, ophthalmic solutions or topical solution. Many chemicals are only slowly soluble in a given solvent and require an extended time for complete dissolution. Dissolution rate can be increased by one of several techniques such as applying heat, reducing the particle size of the solute, utilizing a solubilizing agents or subjecting the ingredients to rigorous agitation. In most cases, solutes are more soluble in solvents at elevated temperature than a room temperature or below due to endothermic nature of the dissolution process. Certain chemical agents, particularly calcium salts, undergo exothermic reaction as they dissolve and give off heat. For such materials, use of heat would actually discourage the formation of a solution. Example is calcium hydroxide, which is used in the preparation of calcium hydroxide topical solution USP, United States Pharmacopoeia. This solute is soluble in water to the extent of 140 mg per 100 ml of solution at temperature 25 degrees centigrade and 170 mg per 100 ml of solution at temperature 15 degrees centigrade. Thus, the temperature at which the solution is prepared or stored can affect the concentration of resulting solution. Solution intended for oral administration usually contain flavoring agents and coloring agents to make the medication more attractive. Chemical and physical stability of medicinal agents improved by addition of stabilizers and growth of microorganisms prevented by addition of suitable preservatives. Chemical interaction which may occur between the various components of a solution which may result in an alteration in the preparation. Stability and potency. For example, ester of para-hydroxybenzoic acid, frequently used preservatives in oral preparations, have a tendency to partition into certain flavoring oils. This partitioning reduces the effective concentration of the preservatives in the aqueous medium below the level needed for preservative action. Dry mixtures for solution. Certain antibiotics have insufficient stability in aqueous solution. They provided in the form of dry powder or granules form for reconstitution with a prescribed amount of purified water immediately before dispensing to the patient. They can store only for 7 to 14 days under refrigerator. Example of dry powder mixtures for reconstitution. Fluoxetine sodium for oral solution USP. Method of preparation of solutions. First one is simple dissolution. Dissolving the solute in a suitable solvent with or without heating. Example, adrenaline hydrochloride solution, calcium hydrochloride solution. Solution by chemical reaction. Here, reaction of two or more solutes with each other in a suitable solvents. Example, aluminum subacetate solution. Solution by extraction as extractive. Example, liquid extracts and tinctures. Formulation of a simple solution, for example, aqueous iodine solution IP, Indian Pharmacopoeia. It contains 5% weight by volume of iodine and 10% weight by volume of potassium iodide. The solution prepared by dissolving potassium iodide 100 gram and iodine 50 gram in 100 ml of purified water and adding sufficient purified water to produce the desired volume. Now module 2. Syrups. Now we will discuss about syrups. Syrups are concentrated viscid aqueous solutions of sugar or a sugar substitute with or without flavors and medicinal substances. When purified water alone is used in making the solution of sucrose, the preparation is known as simple syrup. In addition to sucrose, certain other polyols such as glycerin or sorbitol may be added to retard crystallization of sucrose to increase the solubility of added ingredients. Alcohol often added as preservatives or also as a solvent for flavors. Further, resistance to microbial attack can be enhanced by incorporating antimicrobial agents. When the aqueous preparations contain some added medicinal substances, the syrup is called medicated syrup. Flavored syrups are usually non-medicated but rather contain various aromatic or pleasantly flavored substances and are used as vehicle or flavor for prescription such as acacia, cherry, coca. Flavored syrups contain no or very little alcohol. They are vehicle of choice for many of the drugs that are prescribed by pediatricians. Thus, two types of syrups, non-medicated and medicated syrups. Syrup IP is 66.7% weight by weight solution of sucrose, whereas syrup USP consists of 85% weight by volume, corresponding to 64.74% weight by weight solution of sucrose in purified water. Both the concentrations give stable syrups, resistance to microbial growth. Syrup preparations required following components in addition to purified water and medicinal agents. First one is sugar, usually sucrose or sugar substitute. Second, preservatives. Third, flavoring agents. Fourth one is coloring agents, stabilizers, viscosity modifiers. Now, method of preparation. According to United States Pharmacopoeia, simple syrup is prepared and based on cold process. But remember, simple syrup of IP is based on hot process. There are four methods for syrup preparation. First one is solution with heat. Temperature of purified water is increased to 80 to 85 degrees centigrade. Taken off from the heat source, then add sucrose and shake it thoroughly. Those substances that are heat sensitive and volatile agents are added after the solution attains the room temperature during heating. The sucrose gets hydrolyzed, results in the formation of dextrose and fructose. These two sugars together called as invert sugar, and the process is known as inversion. The inversion leads to darkening of the solution. Next method is agitation without heat. Vessel is taken, generally made up of stainless steel or glass. Then the ingredients according to the formulation are added to water and mixed. It is better to dissolve solid ingredients in the water first and then to add them to the syrup. This results in easy mixing as sugar solution generally retards mixing. Next method is addition of sucrose to liquid medicaments. This method is generally used for fluid extracts, but those substances which are soluble in alcohol will precipitate out as soon as the addition of water. An alternation is to first dissolve all ingredients in water. Now, after some time, all the precipitates formed are filtered out. Now, add sucrose. But this method is of no use if the precipitate formed has active ingredients. Another method is percolation method. The principle of percolation is used a sucrose bed is prepared and then water or vehicle containing therapeutic agent is passed. Here the sucrose bed should be coarse and shape of percolator must be cylindrical or cone shaped. Rate of percolator regulates the rate of dissolution of sucrose. Percolate may be returned back to the percolator if necessary for complete dissolution of sucrose. Example of syrup preparation, simple syrup IP. Here, sucrose amount is 667 gram and purified water to 1000 gram. This syrup is prepared with aid of heat. If prepared with all precautions, it does not require any preservatives to prevent microbial growth. Because of its concentrated nature and the scarcity of required water to promote the growth of microbes. This fact can be understood by the following discussion. Syrup IP has density at 20 degrees centigrade 1.313. It means that 1000 ml of syrup weight is 1313 gram. Density is, as we know that density is equal to mass by volume. But IP simple syrup contains 667 gram of sucrose in 1000 gram of syrup. When 1000 gram syrup contains 667 gram of sucrose, therefore 1313 gram syrup will contain 667 divided by 1000 is equal to 0.667 multiplied 1313 is equal to 875.7 gram sucrose. Therefore, the quantity of water present in syrup is equal to 1313 minus 875.7 is equal to 437.3 ml. It means 437.3 ml water is used to dissolve 875.7 gram of sucrose. See, solubility of sucrose in water is 1 in 0.5 ml. Hence, to dissolve 875.7 gram sucrose, 875.7 into 0.5 is equal to 437.85 ml water is required, which is less water present in the syrup to form solution. Thus, practically no water is available for growth of microorganisms. Hence, it is self-preservatives. Other examples of syrups are ferrous sulfate syrup. Ferrous sulfate syrup prepared by ferrous sulfate by taking 40 grams of ferrous sulfate, citric acid anhydrous 2.1 gram, peppermint spirit 2 ml, sucrose 825 grams, purified water to 1000 ml. The important precaution must be taken in preparation is to add ferrous salt in purified water containing some sucrose, which provides a reducing environment. Otherwise, ferrous is readily oxidized by dissolved oxygen to form ferric, which will precipitate as basic ferric salt, resulting in the discoloration of solution. If all sucrose is added, a highly viscous solution is produced, causing difficulty in filtration. Peppermint spirit is used as flavoring agent to mask unpleasant taste of ferrous oil. Citric acid is used to prevent discoloration of the syrup, that is from green to reddish brown, by chelating any ferric which form as a result of auto-oxidation. Now, method of preparation. Dissolve ferrous sulfate, citric acid, peppermint spirit and 200 gram of sucrose in 450 ml of purified water. Filter the solution until clear. Now, dissolve remainder of the sucrose in clear filtrate. Add purified water to produce 1000 ml. Mix gently and filter if necessary through cotton plug. Next example of syrup is codeine phosphate syrup, IP, BPC, citric acid syrups. These are other examples of syrups. Now, module 3rd. Now, we will discuss aromatic water. The USP, United States Pharmacopoeia, defines aromatic water as clear, saturated, aqueous solution of volatile oils or other aromatic or volatile substances. Their odor and taste are similar, respectively to those of the drug or volatile substances from which they are prepared, and they are free from smoke-like and other foreign odor. Peppermint water USP and stronger rose water USP are examples of aromatic waters. Aromatic waters can be categorized into two types as first, simple aromatic waters. They contain purified water as a solvent but do not contain alcohol. Example, chloroform water. Second is concentrated aromatic waters. They contain alcohol as solvent for volatile constituents. Examples of concentrated aromatic water is concentrated peppermint water BP, British Pharmacopoeia. Concentrated water such as peppermint, dill, cinnamon and caraway may be prepared as follows. Dissolve 20 ml of volatile oil in 600 ml of 90% ethanol Add sufficient purified water in successive small portions to produce 1000 ml. Shake vigorously after each addition. Add 50 gram of sterilized purified talc. Shake occasionally for several hours and filter. The aromatic waters are prepared by diluting the concentrate with 39 times its volume of water. Thus, principal difficulty experienced in compounding prescriptions containing aromatic water is salting out certain ingredients such as very soluble salts. Replacement of part of aromatic water with purified water is permissible when no other function is being served than that of a vehicle. Aromatic water will deteriorate with time and should therefore be made in small quantities with time and should therefore be made in small quantities protected from intense light and excessive heat and stored in airtight light resistant containers. Most of the aromatic substances in the preparation of aromatic waters have very low solubility in water, and even though water may be saturated, its concentration of aromatic material is still rather small. The volatile substances from which the aromatic waters are to be prepared should be of purest quality. Now, methods of preparation for aromatic waters. First one is distillation method. The distillation method involves the placing of the coarsely ground odoriferous portion of the plant or drug from which the aromatic water is to be prepared in a suitable still. Still is a part of apparatus with sufficient purified water. Most of the volume of water is then distilled. The excess oil collected with the distillate rises to the top of the aqueous product and is removed. The remaining aqueous solution saturated with volatile material require clarification by filtration. This is common method of preparation of aromatic waters, although it is slow and expensive one. Example, a strong rose water and a national formulary. Second method is solution method. This method is simple, quicker and more economical as compared to distillation method. In this method, aromatic water is prepared by intermittently shaking 2 ml if liquid or 2 gram if solid of the volatile substance with 1000 ml of purified water in suitable container for a period of 15 minutes. After the period of agitation, the mixture is set aside for 12 hours or longer to permit the excess oil and the solid substance to settle. Without further agitation, the mixture is passed through a weighted filter paper and purified water added as needed to bring the volume of the filtrate up to the prescribed quantity. Alternative solution method or by using distributing agent. By this method, the volatile oil or suitably comminuted aromatic solid is thoroughly incorporated with 15 gram of powdered talc or a sufficient quantity of kiselgar or pulp filter paper, and to this mixture is added 1000 ml of purified water. The resulting slurry is thoroughly agitated several times for the period of 30 minutes and then filtered. Powdered talc, kiselgar and pulp filter paper worked as filtrate which rendered the formulation more clear and also as distributing agents for the aromatic substances that ultimately increase the surface area of aromatic substances exposed to the solvent action of water. The distributing agents should be inert in nature. Next method is dilution from concentrated preparation. A concentrated aromatic water is prepared as per formula given in pharmacopoeia. Then 1 ml of concentrated aromatic water is diluted with 39 ml of purified water IP and mixed. Table of example and therapeutic uses of aromatic water is on your screen. In table, various types of aromatic water like anise water, camphor water, caraway water, chloroform water, cinnamon water, dill water, peppermint water. Their concentrated form known as concentrated anise water, concentrated camphor water, concentrated caraway water, chloroform water double strength, concentrated cinnamon water, concentrated dill water, concentrated peppermint water. Now, from concentrated aromatic water, we can prepare simple aromatic water by dilution like 1 ml of concentrated aromatic water diluted with 39 ml of purified water. For example, anise water 1 ml diluted with concentrated anise water diluted with 39 ml of purified water and used as flavor carminative mild expectorant. Second one is camphor water, is concentrated form known as concentrated camphor water. Now 1 ml of concentrated camphor water diluted with 39 ml of purified water, it is used as flavor carminative mild expectorant. Similarly, from concentrated caraway water, 1 ml of concentrated caraway water diluted with 39 ml of purified water and it is used as flavor and carminative agent. Next one is chloroform water. Double strength chloroform water is its concentrated form and from 1 ml of double strength chloroform water, it is diluted with purified water 39 ml and this is used as preservative and flavor. Similarly, like concentrated cinnamon water, 1 ml of concentrated cinnamon water diluted by 39 ml of purified water and used as flavoring and carminative agents. From concentrated dill water, 1 ml of concentrated dill water diluted by 39 ml of water and it is used as flavoring and carminative vehicle, particularly for infants in dry water. Similarly, from concentrated peppermint water, we can prepare by dilution simple aromatic water. 1 ml of concentrated peppermint water diluted by 39 ml of purified water and this vehicle is used as flavoring carminative and weak preservative. Other example is concentrated peppermint water BPC. Here peppermint oil amount is 20 ml, alcohol 90% volume by volume, alcohol strength is 90% volume by volume, amount is 600 ml, purified water up to 1000 ml. Peppermint oil is dissolved in alcohol. Purified water is added in a small amount to the alcoholic solution and shaken vigorously. Suitable amount of talc is dispersed in the solution to absorb the excess oils. Finally, the solution is filtered. Now module 4. Elixirs. Elixirs are clear liquid oral preparations of potent drugs or unpalatable drugs. They sweeten hydroalcoholic liquids intended for oral use, containing flavoring substances or active medicinal agents. Their primary solvents are alcohol and water with glycerin, sorbitol and syrup. Sometimes as an additional solvent and sweetening agents, they are prepared by a simple solution or admixture of the several ingredients. They are used either as vehicles or for the therapeutic effect of the medicinal substances that they contain. Elixirs are clear preparations, but mixtures are often not clear due to the presence of fine droplets of volatile oils present in it. Example, name of the preparation and their uses. Piperazine citrate elixir IP, it is used as anthelmintics. Simple elixir IP, it is used as pharmaceutical aid, and terpene hydrate elixir IP, this is used as expectorant formulation. Vehicle. Vehicle is the main part of the preparation that carries the drug. Production of a clear solution. Flavoring agents containing essential oils or precipitate from plant extract may produce faint cloudiness. To keep the essential oil in solution state, 10 to 20% of alcohol is added. Glycerol is added to keep the essential oil into solution. and to dissolve some ingredients of plant extracts like tannins and their oxidation products. Solution of medicament of low water solubility. If the drug is not completely soluble in water, then a mixed solvent is used to dissolve the drug. Example, phenobarbital is dissolved in alcohol, glycerol and water. Alcohol is avoided in pediatric elixirs, hence in pediatrics paracetamol elixir, propylene glycol is used as the main solvent. Production of a palatable preparation. The vehicle of many elixirs is syrup or flavored syrup, adjuncts or adjuvants like chemical stabilizers. Chemicals are required to make the elixir stable. Example, citric acid, disodium acetate, etc. Coloring agents like amaranth produce magenta red, compound tetrazine. These are coloring agents added in elixirs. Flavoring agents, fruit flavors are used for flavoring purpose. Sweetening agent, example, plain and flavored sucrose syrup, glycerol, sorbitol and saccharin sodium used for this purpose. Fruit flavor, blackcurrant syrup to mask bitter taste of drug, raspberry syrup to mask bitter taste of drug. Now preservatives. Vehicle containing 20% volume by volume alcohol, propylene glycol or glycerol have preservative action. Chloroform and chloroform spirit have preservative action. High concentration of syrups act as preservative. Benzoic acid, methyl paraben or propyl paraben may be used as additional preservatives. Example, preparation of piperazine citrate elixir IP. Here formula for this elixir, piperazine citrate 180 gram, chloroform spirit 5 ml, glycerine 100 ml, and orange oil 0.25 ml, syrup to 500 ml, purified water up to 1000 ml. Method. Piperazine citrate is dissolved in a small amount of purified water, orange oil, glycerine, syrup and chloroform spirit is mixed. Sufficient volume is added to produce the final volume. Now we will discuss about infusion. Extraction referred to process for the isolation of the active ingredients from drug material. This may be by physical means or by dissolving in a suitable mainstream. Liquid solvent, example water or alcohol. Infusion is a method of extraction and it is used for those drugs which are soft in nature so that water may penetrate easily to the tissues and the active constituents are water soluble. Apparatus for infusion, coffee pot or tea pot is the simplest form of apparatus. Sometimes special pots known as infusion pots are used for the preparation of infusions. It consists of a loose perforated shelf resting on a projection near the top of the pot. Method in coffee pot or tea pot. The drug is placed at the bottom of the pot. Water is added and it is well stirred 3 or 4 times during the period of infusion. Second, infusion can also be prepared by enclosing the drug in a muslin bag and then suspending it just below the level of water in a beaker. Stirring is not required in this case because of water slowly circulate due to the increase in specific gravity of water near the drug. In infusion pot, the drug is placed on the perforated shelf. The pot is filled with water and the perforated shelf is adjusted below the surface of water. Final volume is not adjusted. There are two types of infusion, fresh infusion and concentrated infusion. Fresh infusions. A fresh infusion is an aqueous solution of active constituents of a vegetable drug prepared by the process of infusion. Example, fresh infusion of cassia. Coarse powder of drug is used in the preparation of infusion. Water is used as mainstream. The pharmacopoeia states that fresh infusion should be used within 12 hours after its preparation because it gets spoiled due to fungal or bacterial growth. Concentrated infusions differ from fresh infusion in that the concentrated infusions are prepared by maceration or percolation process, and alcohol is used either as a mainstream or as a preservative. An infusion containing 20 to 25% alcohol can be stored for a sufficiently long time. Example, concentrated chirata infusion, concentrated compound infusion of chirata and concentrated compound infusion of gentian. Now we will move toward conclusion. Conclusion. Thus we can conclude that doses form prepared by dissolving the drug in suitable aqueous media, organic solvents or combination of the two. All above discussed dosage form are useful for oral use, introduction into body cavities or external applications suitable for children or people unable to swallow tablet or capsules. Absorption of drug is more when drugs are in the dissolved state. Thus, oral bioavailability, viability means rate and extent of absorption of a drug from a dosage form. Bioavailability of solution form is more than tablet or capsules. Hope you all have enjoyed the lecture. Goodbye, take care and keep it.